Very good morning to students. Today we are going to learn about the estimation of loads acting on the supports in underground excavations. It's a part of geomechanical classification of the rock. That's the RMR-Q-System. With these results, how to your estimation load on the excavation of ground or support. That is, I know my name is Karana Kumar, HOD mining. So the part of rock mechanical strata control. Subtopic is the estimation of loads. This is the underground excavation estimations for related gas testing sir. View is showing here. Coming slides are showing the more in the underground mine areas. The stability of any excavation design of support is very essential. Very essential. A very common practice in underground is to make a estimation of rock load from the strata and its distribution over the mine workings. In Indian coal mines, CMR and RMR and NGI-Q are mostly used for formulation and design of supports in rock engineering. So the rock mass classification Q system both will be the very important parameters. So which you will already last class we learned. Rock load at the time of development in the gallery and the junction can be found out by the CMR RMR. But at the time of depillering, we are using NGI-Q system for the go edge and slice. But calculation of NGI-Q system is very time taking. So we would be use formula that use CMR RMR system, giving a result that is very similar to the NGI-Q system and provides very fast results by involving only one parameter RMR. So we can find out results in rock load at the time of development and depiller frequently and easily. So some introduction part of this area. To estimation of rock load on a strata and distribution over the underground mine workings, very important. We CMR, MR and LP system of the calculation strata pressure at the exposed area of the underground mine. And after calculation of the strata pressure, we can design the support system to estimate the proper economic and safe supports. That is a very idea. Ideological system of engineering, you have to design the support system to estimate as proper economic and safe supports. But in the project, we would only use the CMR and RMR system to calculate the startup pressure at the different places of the mine in the development, as well as in the depillering area by using the different formula. It will give a very fast and easy calculation so that we can design the supports most safely at the danger zone without voiding of the NGLQ system. Accident statistics of the underground coal mine in India. Generally, we have to know that what are the accidents and how the analysis. The India is a country that is largely depending on a coal for the power production and has very largely amount of the coal resource available. There is a lot of coal and that is blocked in a underground mine because of the roof fall and other supports failures phenomena. For the safe uh, extraction of the coal, we have to manage the startup pressure and to design the proper support system as per the distribution of load. In Indian coal mines, mining condition, there are a lot of accidents happening, and most of the serious accidents take place due to the roof fall, side fall, or due to the strata movement. For this concern, continuation efforts is going on to the estimation the exact load to the design a proper and most economic support system for the reduction of these type of accidents. So this is the very essential things of the connection of the why support system is required because of these reasons. So the once you have to concentrate rock property and RMR Q systems to the estimation load. So according to then you provide the a, a economic support system in a particular location, so that to reduce the accidents, that is a not losing of management as well as people those who are working, the give the build up the a confident level to work in the underground mines is very important, because it is not only accident is the loss of the management, it is also loss of the workman, those who are the confidence losing, and also insurance given, the person have to more confident to work under the working our safe environment is also the very essential. These are the interlinking one by one, and also believeness of the workers in the mines also the improved. So these are the interrelationships between the management and peoples, so that a good way of approaching of the industry, interrelationships of the employees is also improvised. So this is the very broad word, accidents word. Most of the cordial relations can be improvised. Once accident, the situation is harmonic will be changed in the mine environment. So think that the accident is a statistics is a very essential phenomena to collection of the mine itself, but it is interlinking to the what are type of accidents. That accidents leads to what is the scientific investigation happening for falling of roof or something. So that will be study this lecture very useful for the estimation purpose. Right, the analysis from above analysis of the above statistics state that the 60% of total accidents underground happening due to the strata movement due to the roof or side falls. The roof or side falls approximate are proportional in both the development as well as the deep districts. The main causes of roof falls is due to the support system design failure. To prevent this type of roof fall, we are using some basic supports plan that uh, maintain that is object the present working object of design support system for the development as well as deep working in order to prevent the accident to the roof fall and side falls in underground wooden pillar. The present system, at the present design support system, a systematic support role should be followed. A design optimization support system means neither more nor less support. It would be help us to the optimize the total cost. There are following supports parameters are the depth of the work is one is a parameter. Height of the extraction is another parameter. Strata behavior, another parameter. Geological conditions, that's another parameter. Span of the area, this is one parameter. Method of extraction, equipment used in the excavation. The present support system for the development and deep working as the following are there. The GOF edge is one of the parameter. At the edge of the GOF, steel props should be made installed skin to skin front block, and the prop should be installed between the chocks also. It would be serve the double purpose. It can be block the road and along the GOF, so that no one can be enter in this area, and at the same time, it would act as a sufficient supports at the GOF edge. So this is some statistics of old years. I think the old statistics for gallons for seeing the what is the rate of accidents. That's for understanding purpose. The year to year this changing because of these old years. I think up to 2015 I have the data. Fall of the roof. The cause of the wise fatal accident in coal mines due to the strata movement. So this is the simple statistics to get understanding them. The what type of accidents is going happening here, categorized to even fall of roof and fall of sides. So every year, the what is happening in the total particular the big accidents, how many, and also percent of accident due to the strata movement. So this statistics is showing that total 60 to percentage of accident due to the strata movement is 60% overall other accidents compared to the other fire accidents, something. But whole strata movement, the 60% of accident is coming to Here statistics is showing that um, so total line drawn 0.6540 is the total accidents. 380 for fall of the roof is more. So this is simplified some data from the mines is collected. So this data is helpful us to to concentrate it which type of accidents can be reduced by our methodology. Go through the statistics, we can easily understand how we will get 60%. Right. Then at the working phase, the go edge you see here before here the go edge at the edge of the go steel prop should be installed at the skin to skin front of the chalk. Uh, Similarly, here is one other calculus page is how uh, do it here. At the working phase, there are following rules for the working phases. The roof shall be installed in the grid of 1 to 1.2 meters at the working phase at the time of development. And at the time of depillary, we use steel props because the span of the area will be increased. The first row from the side pillar is 6 meters, and from the face, the 1.6 meters. So should be installed, and the first row at the side of the pillar should be at least 45 degree inclined to the pillar. The roof should be would be increased by 25% at junction, and you will use the chalk also at the junction. We can use crossbar at the place where the effect of the blasting should be less. In a roof fall occur, in that case we would use the gutter support with the help of the slipper tightly to prevent saggage of the roof. At the place where the roof is very loose, at that place we will use the roof stitching also. So this is the actual formula for calculation purpose, literature review part. So there are a lot of theory about the rock load calculation, but now we are using focus as EMR RMR system and NGA Q system. So Brighton Q system, NGA Q system. So the rock quality index is evaluated as a RQD plus J suffix R, JW, JN and JNSRF. This is a standardized formula for the rock quality index. So rock quality designation, joint roughness number, joint water reduction number, joint set number, joint alternation number, stress reduction factor. Based on value of Q, rock mass can be described as a exceptional good. So Q value 4000 to 400 to the exceptional poor 0.001 to 0.1. By using the Q value, the maximum unsupported span of roof can be estimated by the formula. Span equal to how much? So span equal to 2 into ESR into Q to the power of 0 to the power of 4. Well, what is the ESR excavation support ratio? This is called excavation supported ratio, which is a 3 to 5 for a temporary mine and 1.6 for permanent working. So ESR, that means excavation supporting ratio is should be 1 3 to 5 for a temporary, 1.6 for a permanent workings. So whenever you required for excavation, you should be maintain the 3 to 5. Otherwise, it should be maintained 1.6 ESR value. So the rock load can be estimation from the empirical formula 2 into F by JR into 5. So we know value of where JR value is more than 9 for the particular locations. So such a way that the span of the particular location can be estimated by the ESR value, that is excavation supported ratio value with this empirical formulas. So these are the one important formulas for the calculation purpose. Then, so depending on the different value of the parameters of value of Q, support category has been identified the value of the Q and the rock type. Q values, this is the Q values, the exceptional good, 0.01, 0.1 extremely poor, 0.1 to 1 very pure, 1 to 4 pure, fair and good, 40 to 100 very good, 100 to the extremely good, 400 to 1 to the exceptional good. The rock quality designation index RQD, the percentage of intact core piece longer than the 100 or 10 centimeters or 4 inches in the total length of the core of borehole sample. The RQD value is a sigma of core pieces more than 100 centimeters. This is well-known factor for calculation point of view. When you core is available but discontinuity rate raise values visually in the surface exposure or exploration added. The RQD may be estimation from the number of discontinuities per unit. So RQD is equal to 115 by minus 3 point by way. So sum of the number of joints per unit length can be calculated. So that the table rock quality description by rock quality. So 0.25 the very poor rock and 25 to 50 poor rock, 50 to 7 fair rock, 75 90 good rock, very good rock. The rock quality is concerned. This is being used by the research institutions of the frequently used in the industries also because of the easy to find out that relationship between the rock load as a compared to the Q system. There are five parameters RMR that is given below in the relative ratings. The parameters of RMR, layer thickness, structure features, rock weathering, strength of the roof rock, groundwater seepages. The parameters should be determined individually for all the rock type in the roof, at least the 2 meters height. So description of RMR parameter, the layer thickness, uh, spacing between the bedding planes or planes of the discontinuity should be measured using the borehole strata scopes a long drilling made of the roof. Alternatively, all the bedding planes are weak plane within the roof strata can be measured in many roof exposure like a roof faults area. Shaft section or cross measure drift. Core drilling shall be attempted whenever the feasible and the core log can be used to evaluate RQD and a layer thickness. Average of five values should be taken and a layer thickness should be taken in cm. Structural feature, random geological mapping should be carried out and all the geological features, discontinuity like joints, faults and slips and sedimentary features like a cross bedding, sandstone, uh, should be carefully recorded. The relative orientation, spacing, and degree of the abundance for all these features shall be noted. Their influencing on the gallery stability should be assessed, and the structural index of each feature should be determined with the help of Mebo table. Rock weather, weatherability, standard slags durability test should be conducted on the fresh samples for the mine to determine the susceptibility of the rock to weather failure in the contact with the water or the atmospheric moisture for this treat weight of the exactly any 10 regular pieces of the sample. The total weight of should be also between the uh, 450 to 100 place them for then turf drum into the RPM. So strength of the rough rock also one of the important factor to consideration. Point load test in the standard index test for the measuring the strength of the rock in the field. Irregular samples have to be ratio. For 2:1, for longer axis to shorter axis can be used for the test. The sample is kept between the pointed planes and the load is applied gently but steeply. The load at the failure in the kg divided by the square of the distance between the planter in centimeters give the point load index. The mean of the highest five value out of at least 10 samples test should be taken. The compressive strength of the rock can be obtained from the irregular lump point load index for Indian coal measures rocks by the relations. The CO 14 ones in kg per centimeter square. Groundwater seepages, a 2 meters long vertical borehole should be drilled in the immediate roof and the water seep uh, through the hole after the half an hour should be collected in a measures cylinder. The average of the three value from three different holes should be taken around express in the minutes. The rock mass rating RMR is the sum of the five parameters rating. If there are a more than one rock type in the roof, the RMR is evaluated separately. Each rock type and combined RMR is obtained. As a combined RMR is equal to sigma of RMR of each bed and bed thickness, the thickness of each bed. So that RMR obtained by many adjusted in if necessary to take account for some special situations in the mine like depth, stress, method of working. Rock load in the rock load in the roadway, rockware in the roadway, that ton per meter square, that is a BG2D, that is 1.7 minus 0.07 RMR in plus the value of the rock load in the roadways calculation purpose. So here, here it can be clearly at the roadway, the calculation, the B into D, that is the roadway width and the density of the rock multiplied by the RMR value plus the RMR square. So that the how much load then the road can be calculated by the empirical formula. So there are special classification rock according to rock mass calculations also there. So with this the particular road location, how much load can be expected by this value. So RMR value is very essential for that one. So here is some rock mass rating RMR, rock quality is also given. So rock mass rating is used for design of support in the development galleries. So RMR value is very essential for design of supports. So, however, due to the limitation of its application, deep learning working, many investigators adopters various approaches such as a Q qualification of rock mass, numerical modeling, etc. for a design of support system in a deep learning working. Sometimes it is also required to the design supports in the deep learning panel, having widely varying geomining conditions within the different supports. Estimation of rock load in the slices by the RMR. The rock load in a slice, the T by M square equal to 5.21 by 2 in rock load and in road base, so minus 0.213. So estimation of rock load in the GOF edge by the RMR. Rock load in the GOF edge is different. GOF edge is this formula is rock load in the slice and GOF edges in the given by the above equation new correlated. It is with the rock load in the roadway. The correlation round between them is 0.73 and 0.775. By CMR and RMR system only estimation workload in the turnover gallery splits Slices, goaf edges, and depillering panel of board and pillar mining by using equation for slice and goaf edges. Um, this is a simplified RMR calculation chart for the understanding purpose. And elaborated some more to see understand. Yes, yes, you can able to see. So here we were given all the strength of the intact rock material, point load strength index. So this is a other range of the values for the low range unvaried compression strength. So these are the rating of the RMR calculation chart for the particular rock area. And then coming to the rating. So flow sheet for the driving RMR, divide the mine into the area of the similar geological roof control problems. So estimation of extreme cases, identify the 5 locations, identify rock units in the roof. So rating is structural feature index, layering thickness, slag durability, point load index, compressive strength, groundwater. So these are the clarifications. So RMR equal to A plus B plus C plus D plus E. So what is the A, B, C, D? So adjustments, depth of adjustments, the combined RMR for all in the rock units, RMR for all the whole area, minimum of 5 locations, adjustment of the RMR, estimation of rock load, select a support system for each area. This is for the sheet for derived from the RMR or flow sheets from driving RMR. So gallery span for adjustment, extraction method, so induced stress, later stress, depth of adjustments. So the A, B, C, D, E of overall, that is a structural feature of index. That is also value rating, and layer thickness. We are giving the rating. Slack durability. We are giving the some rating. So point load compressor. We are giving some rating. Groundwater. So A, B, C, D, E up to 1, 2, 3, 4, 5. 5 factors we have to add it into. We'll get the RMR value. So RMR based on RMR, the how to depth of the adjustment and lateral stress will be calculated. So then the simplified one more idea here. Scheme of experiences. Sample calculation of rock load by RMR system with assumed mine condition and data according to the parameters of RMR. Condition mine as follows: strength of the intact rock material. The universal compressed strength is 137 megapascals. So according to table, the A is equal to 12, drill core quality, that is a RQD value 62%. The value B is 13 according to value of RQD. The R rock is fair good as written in the table. The spacing of discontinuity, condition of discontinuity, the groundwater conditions. So according to these 5 parameters, we can be calculate the RMR of the rock by adding these values. Now the value of RMR is A, B, C, D, E. So according to table, we have seen that the rock is a fair. A gallery with 4.5 meter density rock is 2.25 tons per meter. So some more here. Support design in a gallery, a rock load in a roadway, ton per meter square, then 2.44 ton per meter square. Factor of safety is 2. Required support resistance 4.88 ton per meter square or more. Strength of one bolt, required supports resistance in a gallery for the 1 meter length. The number of bolts required in the row, 22 by 6. So that around 4 bolts are coming. So number of rows should be arranged in a fashion that the first bolt from the pillar should be 0.6 meters from the pillar, and where the rest are 1.2 meter from the each other. The distance between the two rows should be in meter. Support design at the junction. Area of exposed roof, that is a 4.5 into 4.3, that is 20 meters exposed area. The total roof load coming, the required support resistance, the total number of roof bolts required. So this is the, we know that we have to increase the roof bolts by 25% at the junction. The final number of bolts is equal to the value we give. So we'll put the supports 1 meter grid at the subjunction, as we know that the roof bolt is a permanent support, so as to we will apply some temporary support just like chalk and slipper at the place of the junction. The support design at the slices according to the equation. The rock load in the such slices, the width of the slices, and we assuming factor safety by 2. So this is support design at gallery particularly, simple calculation purpose. So total load coming is equal 20 tons, for example, required support distance is 40 tons. So that is a factor safety. So double that one. So work load is expensive 20, but factor safety 2 means double that one. So number of bolts required 7. We will put it a roof bolt, 0.8 meter grid, and installed more temporary supports like chalk supports at the 2.4 meter interval, and triangular supports at the face of slices. Support design at the go edge according to equation. Rock load in the go edge to 5.28 ton per meter cube. Rock load coming into go edge. So required support resistance, number of roof boards. We will be installed the roof board at the go edge in the interval of 0.5 meters, and we will install that skin to skin hydraulic props in the front of the chalk. Supports the go edge and prevent the go roadway. So no man can be enter in this area, and the roof fall effect or will also be reduced by this way. So and then coming to the from the other conclusions of the this before I going to the other slides, conclude some more support the edge of the growth load slices formula they were given. So other objective of these calculations, particularly these two uh, phenomena are seen. Development galleries, working faces, slices, and co-edges support development will be deep link panel is also required. Support determination of parameters is the depth of the working, height of extraction, strata behavior, geological conditions, and span of area, method of extraction, equipment used in the excavation are the more important for the estimation of load in that. Particularly, main purpose of supporting is excavation mine is to maintain the dimension during the life of the opening and safeguard the people and the machinery working it. The excavation in the underground are made under the variety of geological condition. A number of theories have been put into forward in the past to explain the phenomena of the movement of rock into the excavation and to estimation of load on the subfloors. In a one group of these method, the theory of the elasticity is applied to identify the first and stress conditions prevailing in the rock in the original undisturbed condition, and then the distribution of the stress and a strain introduced by excavation as a derived. The concept of the stress functions, though are soluble, allowable in the principles of the ideological condition, the computation of the quite tenderness, the involving the evaluation of number of constant. In fact, there is a fundamental description between the basic assumption introduction and actual condition in the underground. These solutions are perhaps more useful for a demonstration of the influence of individual parameters. For the very narrow openings, what are the theory involved, those who taken into account the complete static weight of the superincumbent rock, friction according to the correction in the theory. So this is the one simple Q system of already you are aware that in calculation. So according to that one index we will be derived from this formula that is already given in early slides also. So this is a noted one Q system is concerned. The most of the NGI National Geographical institutions use this quality index. The quality index based on you can be support design. It can be. This is the application of system application of Q system. The simplified maximum unsupported span length double into ESR. ESR is exposed space ratio, excavation support ratio. Rock load can be calculated by the this same 2 into F by G R by 2 where this area. So estimation of rock type, Q value and Q type. This is another percentage of intact core piece longer than the 100 mm. So 4 inches in the total length of the core. So rock quality description by the RQD. So this is a generalized CMR recommended parameters for RMR. Layer thickness and structural features, rock weatherability, strength of the rock, groundwater seepages. The 5 parameters about determine individual for all the rock type in the roof at the 2 meters height for the parameter for RMR with the rating, layer thickness, structural features, rock weatherability, strength of the rock, strength of the rock, groundwater seepage. And next, the combined RMR value can also be for the rock type in the roof. So rock quality description by RMR, rock mass rating. This is one of the parameters also you see. So applications of RMR. So overall, you see above theoretically, what is the mean by RMR? See, what are the other important factors in that one? Let us see this application in the coming slides. So, for example, the calculation of rock load in the roadway. This is the application of the rock value, rock value, rock mass rating, rock mass rating. B is the breadth of the roadway and D is the density of the roadway. So by this, it can be any roadway calculations. Calculation can be possible. This is the application of the RMR, rock mass rating. B is multiplied with the D. The D value will be symbolized standardized 1.7 minus 0.37 RMR plus 0.0002 into MMR square. So when you are applied any rock load in roadway, can be calculated by this one. So provided that you know the RMR value. So from RMR, how will you get to this is the RMR values. So from this, here you given yes. From this you can be calculated Q value. So by this application, you can be load calculation in the particular location. Okay, and also another estimation of the rock load in sites. How to estimation of the rock load in the sites by RMR. So rock load in the slice, that is the T by M square, the thickness of by the, so 5.215 multiplied with the rock load in the roadway minus 0.213. So estimation of the rock load in the go edge. So that is the estimation 7.35 into multiply the rock load in the road face minus 1.28. So when I put it to the values in this particular location, we'll get the how to how much load will carry. So accordingly, we can be put into the that supports. So this is the one chart showing here. So strength of the intact material, point load strength index. So more than 10. Ranges of the value 4 to 10 to 2 to 4, the 1 to 2. For this low range, uniaxial compressive test is preferred. So similarly, uniaxial compressive strength megapascal more than 250, 100 to 250, 50 to 100, 25 to 25. So rating, drill quality, RQD percentage, rating, spacing of discontinuity, rating, the condition of discontinuities. So rating, and also ground water inflow of for the how general conditions. So this is the complete chart for the sample calculation for the chart. So many theories also there. Theory of supporting there will be simplified the rock pressure theory developed by uh, basic observations in underground excavation, development of rupture surface beginning edge of the excavation appearing as a vertical cracks. He assumed the rupture failure take place along the curve surface rather than along a plane. The profile of the surface according to derive the following expressions. Depth of the excavation, width of the excavations also, angle of fractures also taken. Protodiagnometry also one of the estimation factors. That is also assumed to excavation pressure arch. A parabolic shape is formed, weight of the strata laying outside the arch transfer to the excavation. Different theories also available in the scientific analysis purpose. So sample calculation for the experimental observations, RMR parameters, strength of the intact rock material. That's already we're given in above slides. Similarly, we are also given here. Annexure compressive strength, drill core quality, spacing and discontinuities values. These are important. The value of RMR, A plus B plus D, we take is according to the RMR, we can see the rock fair. The gallery width is 4.5 meters. The density of the rock is particular. That will be can be estimation of. For example, a support design in the gallery. See it here, the simple methodology. So rock load roadway is equal to 2.44 ton per meter square, factor of 52. Required support resistance is equal to 4.8 per ton per meter square. or more strength, 1 bolt, there is a 6 ton. Required support resistance in gallery for a 1 meter length. So 4.8 into 4.5 into 1 is equal to 22 tons per meter square. The number of bolts required in a row, 22 by 6 and 3.66 are 4. The roof bolt should be arranged in the fashion that the first bolt from the pillar should be 0.6 meter from the pillar, and the rest are 1.2 meter from each other, and the distance between the two rows should be 1 meter. So area of exposure of roof is 4.5 into the, so this is the estimation value. The total rock load coming the 49.5 tons. The required surface resistance is the double that one. So as per the total number of bolts required is equal divided by 6. One bolt is a 16.5 tons. So we know that we have increasing a root bolt by 25% junction. So as the final number of bolts required is 16.1. So 1.25%. So 21 bolts are required. So we will put it to the supports at 1 meter grid at the junction, as we know that root bolt is a permanent support. So as we will apply some temporary support just like chalk and slipper at the place of junction. So other according to previous equation terms RMR, so rock loads for slices, that means 4.43 ton per meter square. And width of the slice is 4.5 meter, assuming the factor of safety by 2, then total load come to the uh, 20 20 tons. So required support resistance 40 ton. So number of roof bolts required 7. We'll put into the roof bolt in the 0.8 meter grid and installed more temporary supports like chalk supports at the 2.4 meter one, and regular triangular supports at the face of the slice. So this is the other type of phenomenon for a slicing concern. Then support design at the go edges. So according to previous equation, rock load in the go edge is equal to 5.28 tons per meter square. Rock load coming to that go edge is equal to 23.76 tons. Required support resistance is 47.53 tons. So number of roof bolts are 8 required. So we'll be install the roof bolts to install the roof bolts at the go edge in the interval of the 0.5 meters, and install the skin to skin hydraulic prop in the front of chalk supports go edge and prevent go roadway. So no number of can be in term the area, and the roof fall effect will also be reduced by this way. Well, we go to the concluding that one. So overall, the basic idea of design of any first estimation of the load is very important. For estimation of the load, we require the particular rock mass rating. As per the CMRI is concerned, rock mass rating is important. For rock mass rating, we just go to the Q system. Q system as per the RQD value into J, water conditions, space conditions, discontinuity conditions. So that are 6 parameters we have to calculate value to get it. But for that particular value, we put into the specified junction and also road gallery, slices, and also GOF areas. So particularly you put into that value that one, the load can be estimated. From the load, the factor safety is double that one. So for example, 50 tons, 100 tons is required. So 100 tons, the how many roof bolts can be bare divided by the number of supports, each supports in. So that will be planned such a way that the exposed area ESR, excavated roof support ratio, where according to we design the support systems. This is the overall idea of the RMR versus rock excavation exposed area support parameters. So these three are the you have to scientifically methodologically movement is required. Now I am going to conclude. RMR is sufficient for the rock load calculations. Yes, mine has a heterogeneous rock type, and this case it is very tough find rock load in every place. It is very economic, reliable, and easier method. RMR method. So I hope that first you had to know the how to RMR value is calculated, how to this application to the mine different locations. I hope that today you are enjoyed your class well. I wish you the all the best, and also thank you very much.